So in the beginning, I mentioned that the reason why we want to study matrices is because we want to solve system equation in a more efficient way. So let me give you a very basic example. Suppose you're given the following really simple system equation. So this one, okay, x plus 2y equals 3 and 3x plus 4y equals to 1. Firstly, observe that the left-hand side can really be rewritten as the form 1, 2, 3, 4 and the xy. And it equals to 3, 1. So think about that. I really didn't do any mathematics. I just rewrite this system of equation in a matrix form. If you multiply the left hand side out, you realize that what you get is really x plus 2y and 3x plus 4y. That is exactly the left hand side of this system equation. And then somehow people are lazier. They think that even writing a system equation like this is troublesome enough. They're going to drop the variable and then rewrite this as 1, 2, 3, 4 and then 3, 1. Okay? Some people will write this line and some people do not. I write this line just to remind myself there's an equality between the left hand side and right hand side. Okay? So think about that. I didn't really do any mathematics. What I did is basically rewrite this system equation in a much lazier form only. Okay? But how did we solve this equation when you were younger? Oh, yeah, we labeled the equation by 1 and 2. And then what we try to do is to use the method of elimination. We try to kill the 3x here. How do we kill that? That is by multiplying the first equation by minus 3 and then add it to the second equation. Okay? So if I multiply the first equation by minus 3, then add it to the second equation, then I get minus 3x cancel, and minus 6y, 4y become minus 2y, and then minus 9 at 1 become minus 8. So from this, we can solve for y equals 4. And then hence, by putting that back to the first equation, then you get x plus 8 equals to 3, so x is minus 5. So we're going to do the same process, but in matrix notation. So let's have a look. So I have 1, 2, 3, 4, 3, 4, 1. And then what I'm going to do is to kill this guy here. How do you kill this? That is by multiplying the first row by minus 3 and then add it to the second row. Okay? Let's do it very slowly. So multiplying the first row by minus 3 and then add it to the second row. Then this will become the first row unchanged. And then multiply 1 by minus 3, so you get minus 3, add it to 3, you get 0. 2 multiply by minus 3, you get minus 6. Minus 6, add it to 4, you get minus 2. And finally, 3 multiply by minus 3, you get minus 9. Add it to 1, you get minus 8. Then, after you do this, you realize that the second equation reads as, okay, so what does this mean? It means minus 2y equal to minus 8, so y equals to 4. Okay? And after you solve y, you can solve x because the first equation reads as, so if you look at the first equation, you have 1, 2, 3, that means that x plus 2y equals to 3. That means that x plus 8 equals 3, so x is minus 5. So really, we didn't do any new mathematics. What we really do is we transform the trick you learn at junior high school method elimination in matrix form only. Okay? And the operation that we wrote down here is an example of what we call row operation. Okay, row operation. So this stands here. So row operation is nothing challenging. It's really just operation that are permitted in solving equations. So for example, just now we have learned a trick that is the method elimination. Method elimination is really try to replace a row by itself plus a multiple of another row, right? Because for example, here we replace the second row by second row plus minus 3 times R1, okay? So this is what we did just now. And now, of course, there are more easier operation you can do on an equation that does not change the solution to an equation. For example, you can switch two rows, because if you switch the order of the equation, it does not change the solution of the equations. Also, you can multiply a row by a Longzhou scalar, by a Longzhou number. You can scale up an equation, and that also does not change the nature of the equation. So these are the three basic row operations you can do to a system equation, and they collectively call the Gaussian elimination. Elimination. Okay, sorry for the spelling. And that is what I mentioned here. Okay? And now on the next page, we're going to do a few more examples on Gaussian elimination in how to resolve system equation.